let's say the first rule where there was y equals constant. So instead of constant, I put 3.9. Let's put minus 3.9. Okay, so I want to differentiate with respect to y. So I'm in with respect to x. dy over dx equals to d over dx of minus 3.9. You don't have to look what the sign is. The answer is just a 0. What does that actually mean? It means the y is not changing, but the x, if I change the x, the y is not changing. If I plot a graph of this equation, y equals 3.9, the graph is going to look something like that. So y is 3.9, which means the graph is going to be somewhere here. So let's say this is 3.9, or let's say 4. So this is going to be the equation, yeah, of this line. Yeah. This is the equation of y equals to minus 3.9. What is the gradient here? The slope. The slope is 0. When something is horizontal, the gradient is 0. When something is like going up the hill, gradient is positive, and something is going down the hill, gradient is negative. So here the gradient is 0. You can see the x is changing at that point. The x is changing, but the y is still 3.9. At this, the x is changing, but the y changes 0. X is changing, now x is like 2, 3, 4. The y is still no change, minus 3.9. The value of the y here is minus 3.9. So y is not changing at any point. This thing, no change. Even that is changing, which means the temperature of this room is constant. It's set constant. So no matter if I got a really good system, no matter I come morning, evening, whenever time, the temperature of this room is 19 degrees centigrade. So it's not changing. Yeah. Okay. So that's the first rule. Now the second rule is example of second rule is, let's say I have y equal 3 over 5. Yeah, 3 over 5 x, or 3x over 5, doesn't matter. Instead of k, I put 3 over 5. That's a constant. So I need to differentiate. Now I need to differentiate with respect to x. So that will become dy over dx equal d over dx 3 over 5x. So 3 over 5 comes out, and you only need to differentiate the x. Now you know this bit is 1. So 3 over 5 times 1, which is 3 over 5. Now this one we already know, according to one of our rules, that dx over dx is 1. Yeah. So that's the value. So what you need to do is you just need to actually put the constant as an answer. So the other thing you can just like delete straight away. Okay. Now the next bit, the important one. If I got this bit, now let's say I have y equal to x to the power 7. I need to differentiate that one. So I'm going to do dy over dx equals to d over dx of x to the power 7. The rule says power come out. What's the power? 7. 7 comes out. Reduce the power by 1. 7 minus 1. 7 minus 1. And then you just differentiate whatever is here. And we already know 7 is a 7. X to the power 7 minus 1 is x6. And this thing is just a 1. This dot being multiplied. Yeah? So the answer is 7x 6. That's a dy over dx. That's how we do. Yeah. Obviously, at this point, I am doing all the steps. You don't have to do these steps later on, but initially I want to learn the steps. Later on, if I got this thing, y equals to x to the power 7, I can take the power out, reduce by 1. So in one step, I have to write this bit, and I have to write that bit. And next step, I would straight away do this, 7x to the 6. Yeah. Okay. Now, one last one. Let me do this one here. And let me just call this one number 4. Let's say I go y equals 5x4, and I want to differentiate. Okay, so dy over dx equals d over dx of 5x4. I need to use multiple rules there. The 5 is a constant, so 5 comes out first. Now then I have to do what I do there. The 4 comes out, reduce the power of x by 1, 4 minus 1. I don't have to even write dx or dx. I'm still going to do that one just so you know. This thing is actually a 1. 5 times 4 is 20. I got 20, and then I got x cubed. This is 1. I don't have to write 1. So that's the answer. Okay, that's it. Let me see if the